legalizefreedom.com. Why are we here? Where do we come from? Where are we going? From the nature of reality to the future of humanity. Listen without limits. Unchain your brain. Change your thinking. Change your life. legalizefreedom.com.
Greetings and welcome once again to legalizefreedom.com. I'm your host Greg Moffat, and my guest today is Marc Defant, who joins us to discuss the apparent lack of evidence for extraterrestrial life in our solar system, the wider galaxy, and the entire observable universe. The Fermi Paradox states the situation as follows. There are billions of stars in the Milky Way similar to our Sun. With high probability, some of these stars have Earth-like planets. Many of these stars, and hence their planets, are much older than the Sun. And if the Earth is typical, some may have developed intelligent life long ago. Some of these civilizations may have developed interstellar travel, a step that humans are investigating now. Even at the slow pace of currently envisioned interstellar travel, the Milky Way galaxy could be completely traversed in a few million years. And since many of the stars similar to the Sun are billions of years older, the Earth should have already been visited by extraterrestrial civilizations, or at least their probes. However, there is no convincing evidence that this has happened. So the question is, where are all the aliens? Hello and welcome, Marc, and thank you so much for joining us today on legalizefreedom.com.
Hi, Greg. Good to join you.
Now, today, Marc, we're going to be asking the question, where are all the aliens? Referring to extraterrestrial life, intelligent or otherwise, in our solar system, the wider galaxy, indeed the observable universe. Before we dive into that, for listeners who don't know, just tell them a little bit about your background and your work in general.
Well, I do my research in geochemistry and volcanology, so I'm primarily out on volcanoes, but I have taken an interest in skeptical inquiry, and in particular I gave this TED talk on why we might be alone in our galaxy. And I've written a book on the history of Earth, universe, and life. So it's given me a perspective about the difficulties, seemingly, of getting life on this planet. So that's what kind of launched me into my interest in whether there's intelligent life out there or not.
Now, as I mentioned to you off air, most people, whether they have any specialist knowledge in any of these areas that we're going to be discussing, they feel kind of intuitively, instinctively, for whatever reason, and sometimes it can be quite emotional for people, whether they admit it or not, quite deep-seated psychological reasons why they feel there must be something out there. A lot of people find the idea that we might be alone, never mind in the solar system, but perhaps the entire galaxy and beyond. They find it quite horrifying, really, at a sort of cosmic level. Very difficult to contemplate. It's just that idea of loneliness, isn't it, really? And it's one thing to be alone amongst your own kind on your own planet, but the idea that there could be absolutely nothing else out there whatsoever, that everything that we see out there is just cosmic debris, is really an assault on the subconscious, I feel. So what do you feel about that, particularly when it gets to people's psychological and emotional feelings about it?
Oh, that's funny that you should bring that up, because I didn't recognize that. And when I gave my TEDx talk, I didn't have any sense of that. I don't feel that way myself. So because I've never thought that there would be intelligent life visiting the planet. So I guess it never kind of hit me that people might be emotionally involved. But boy, I kind of hit a buzzsaw when my TEDx talk got out there and I went on the Joe Rogan show and so on. And people were seemingly quite hostile to my position. I wasn't out to make people upset. I was simply talking about the possibilities that there may not be any life out there based on some of the things that I've looked into. And we can talk about that if you'd like, or we can talk about the Fermi postulate, whatever way you'd like to go.
Well, we'll get to your own particular feelings that you mentioned in your TED Talk, and that's to do with the conditions seemingly necessary for the evolution of life as we know it. But you mentioned that Fermi Paradox. This is, for people who don't know, I've mentioned it in my introduction, but basically it's Fermi Paradox. Anyone can look it up. In fact, there's a link to it in this program description. And it essentially says, boiling it down, that there are billions of stars in our own galaxy, which are very similar to the sun, and the chances of there being Earth-like planets out there are quite high. Many of these stars and the planets around them are much older than the Earth and the sun. And basically it's a statistical likelihood, depending on how you look at it, that other life, as has evolved here, should have evolved somewhere else given similar conditions. And that even given the difficulties of traversing interstellar space, if we forget starships, just thinking about communications methods, that by now we should have had some inkling, some indication that there is something out there, as I say, even just in our own galaxy. But so far, nada, zilch. And this is addressed, the counter to this is the so-called Drake equation, which estimates that there should be anything from 1,000 to 100 million Earth-like planets just in our own galaxy. And again, that's heavily suggestive of that there should be something out there. So I think that's the circle that we're trying to square here. But you feel that essentially your position, as I mentioned earlier, off air, could be summed up by the so-called fine-tuning hypothesis, or perhaps the rare Earth hypothesis, that basically the conditions for life are so implausibly rare as to make it possible that we are it. So perhaps you could just elaborate a little bit about your own personal view on this.
Sure. If you don't mind, let me get into a little bit about the Fermi Paradox. And, Fermi was a brilliant guy. And I've read the story, I don't know if it's true or not, but I read the story about how his friends learned of his thinking on this. He was at the University of Chicago and, of course, was a big figure in the development of the atomic bomb. And one day, apparently, he came into lunch and he just out of nowhere said, "Where's all the life?" And his colleagues were like, "What are you talking about?" And he said, "Well, if there is intelligent life out there, we should see all kinds of signs of it." And the idea was that if intelligent life developed and evolved on other planets, that they in turn would probably populate other planets until the entire galaxy or galaxies were populated, so that communications may not be fabulous between the edges of galaxies, but all the life in between would be communicating with each other, and we'd have a veritable smorgasbord of activity out there. And as you so rightfully noted, we have nothing. What SETI's been around for 54 years or something, more maybe, and there's been no sign whatsoever of. Now, there would be people out there, I learned from my TED Talk, that have run into, they claim, aliens and talked with them and so on, but I haven't seen, and I don't think there is, any real documented evidence of alien visitations. So, why do I think that life is rare out there, intelligent life? First of all, let me explain, because I don't want to be misunderstood on this. I suspect that life out there may be fairly common. I just don't think that intelligent life is very common. And that idea comes from my work on my book, which I mentioned earlier is called A Voyage of Discovery. I'm working on a second edition now. It's about, it really is the history of the universe from the Big Bang all the way to the life evolving on our planet, and the subsequent evolution of life. and even go through to the evolution of humans and our most recent ancestors. And I realized that getting human life seems to me to be somewhat seems statistically remarkable. A lot of things, strange things, had to happen. Now I know that to some extent that assumes that all intelligent life is going to evolve like us, but I don't think that's such an idea that would or should upset people, because there are only so many different environments that you can have on planets. And we probably have most of the environments that one would encounter on other planets. I think, anyway. We have oceans. We have, I think, there's some weird things on Europa and some of the other planets. One of the planets has, or one of the moons has, a hydrogen-rich ocean. So I guess there's some environments that, that we're not familiar with where strange, intelligent life could evolve. But if we're talking about planets that look like Earth with water on them, I just think that we're probably limited to seeing life like we see it here, life that walks upright with brains like we have, because of the evolutionary process. If you take dinosaurs, for example, they were an immensely successful group of animals for, 125 million years. And then what were mammals during? Well, they evolved, but they were really somewhat small, scurrying around. They certainly didn't dominate the planet like dinosaurs. And I'm not sure if the dinosaurs had survived, they would have evolved the way they have. The dinosaurs, though, one thing is clear, in 125 million years, they never evolved intelligent life, at least intelligent life the way we define it. So the conclusion there is we need something more than a lizard-like brain or even a bird brain, which, of course, birds are derived from or evolved from the dinosaurs. So my thinking is that you need a neocortex, which mammals have. And so maybe if we hadn't had a meteorite that struck 66 million years ago and wiped out the dinosaurs, we may not have had the mammals reaching into and becoming the main group of animals on the planet. They may have remained small. They certainly were fairly minor animals when the dinosaurs ruled. So that was my first clue that we might be dealing with something kind of odd here. We first have to get rid of these large dominant creatures, perhaps. And I say perhaps because, who knows? There's, only been one Earth that we know about. So, but it's fairly clear that after the mammals evolve, they go into trees. And we get prosimians and then eventually monkeys, and we go on to evolve the great apes. And then in the process of developing the great apes develop large brains. The reason for that, there are many reasons, but when you have to jump from limb to limb, it's probably a good idea to see in three dimensions. It's a good idea to see in color. And you develop fine-tuning of your digits so you can grasp onto branches. So it requires a significantly larger brain than some of the mammals that simply roam on the planet. And so once we've evolved these digits, we still don't have brains big enough to create what we would define as intelligent life on the planet. I'm not saying that apes aren't intelligent. I'm just saying that they're not intelligent enough to communicate the way we do and develop technology, etc. So we also have to have another unusual thing. We have to somehow get those great apes out of the trees and onto the ground, because apparently whatever process, and we're not precisely sure what caused the development of our brains, but we see it in our ancestors that very quickly Australopithecus and even ancestors prior to Australopithecus had ape-like brains, and after that, once they get on the savanna, they start developing these huge brains. They go from Australopithecus to Homo habilis, to Homo erectus, and eventually to us, Homo sapiens. So something's going on out there in the savanna. It didn't happen in trees. I mean, we've had monkeys around for 40 million years, and still no life in trees ever created an intelligent being like us. So apparently you have to have these bigger brains that are in trees, that evolve in trees, forced onto the ground to live on the plains. A lot of people suspect that it may be our need to walk upright and carry things. Walking upright, of course, allows us to see greater distances on savannas so we can protect ourselves from predators. Carrying things and being able to swing clubs may have helped us in savannas. And our ability to walk upright got us between food sources where fruits were rare, so we could move from one site to another. And of course, communication can't be ignored. Probably communication had a major impact on our developing intelligence. So where else could this kind of environment develop? Well, we haven't seen it in the oceans, that's for sure. So I sort of came to the conclusion that, you know, it's not so simple to evolve intelligent life, and maybe it might be more rare than people think it is. Now, I guess one of the things that I should say to clarify my stance is that intelligent life is, the way we have it here is difficult, but perhaps there are some ways I'm not thinking of that get intelligent life all the way out there. I do know from reading other books that the rare earth hypothesis postulates or talks about a lot of other rare events that have taken place that I didn't have time to talk about in my TEDx talk, like we have to be in the Goldilocks zone around the sun and in our galaxy. And so there are a lot of other things that have to take place seemingly to get intelligent life. And if you look at the Drake equation, which you mentioned earlier, that Drake equation, if one of those parameters in the Drake equation is 0, then the chance of intelligent life out there outside of our Earth is 0. So we only need one of those events to be 0. And one of the things that the Drake equation doesn't address directly is what are the impacts of all of these seemingly statistically rare events? How do they impact that Drake equation? There's no way to really quantify that, because they are all sort of, if you need a meteorite impact, for example, what's the chance of that wiping out the dinosaurs? If you need a neocortex, what are the chances of devolving a neocortex in mammals? If you need larger brains that see in 3 dimensions and color, what are the chances that mammals would go into trees with neocortexes and evolve and then go down on the ground? So I hope I've summarized a little bit about the point I was trying to make and clarified it to all the people that might be listening that heard my TED Talk and were upset about it.
Well, it's also, in terms of intelligence elsewhere in the solar system, galaxy, universe, it isn't even simply a question of intelligence, it's also what you do with it. And also, in terms of building and communication, for example, on Earth, we know that we have species, dolphins, whales, even the octopus, demonstrating high levels of intelligence, very sophisticated communication, but they're not building anything, and they're certainly not reaching out beyond the planet. They've been existing for longer than we have in our current form, and basically, as far as we're concerned, haven't done anything. Of course, they don't have any drive to do that. So conceivably, there could be intelligent life elsewhere that just doesn't have any of the instincts that we seemingly have to explore and to reach out and to wonder at what else might be out there.
Yeah, you bring up a good point, Greg. There's a fine line between intelligent species, like I think dolphins and great apes are intelligent beings, but there seems to be a difference between what they've been able to accomplish in terms of their abilities to function on Earth and what we've been able to communicate or accomplish. And I'm not trying to sort of knock dolphins or great apes. I'm just saying that intelligence like we have, ability to build civilizations, the ability to communicate the way we do, the ability to develop technology, and this whole world of science, that takes seemingly a pretty special creature. And I would also mention Neanderthal. Neanderthal had a huge brain, bigger than ours, but for whatever reason, Neanderthal went extinct. Now, I know we have some Neanderthal DNA in us. I think Neanderthal DNA is found outside of Africa, but I don't know. I think it seems like Denisonians and Neanderthals have about 2 or 3% DNA, or we have about 2 or 3% of this of their DNA in us. I'm not sure. I haven't read recently. There may be some in Africa too, where they came out of Africa and then went back in after they had mated with Neanderthals and Denisonians. But I haven't kept up with the literature on that. Awful lot to read out there.
There's a lot of excitement in popular science articles these days about the discovery of exoplanets. I can't remember off the top of my head when the first one was discovered. Was it maybe like 1995 or something like that? Relatively recently in terms of astronomy, but the way these discoveries, and many of them, to be honest with you, when I've looked into it, their previous discoveries being re-announced. I think a lot of popular perception amongst lay people is that particularly when they see artists' illustrations of exoplanets, they think they're photographs, and they hear lots of frothy speculation about potentially might have water. They hear talk of habitable zones, within in proximity to their relative stars. Earth-like is a phrase that's bandied about a lot. So I think this fuels the idea that there should be intelligent life out there, and that each new exoplanet announcement seems to further stoke the expectation that we're getting closer to making a discovery like this.
Yeah, you make a good point. I get a lot of tweets or emails where people say, "Oh, we've discovered all these exoplanets. Don't you want to back off of your position?" And my response to that is that I've known for a long time that we had a lot of exoplanets out there, and we've even found some exoplanets now that are very close to Earth in size and in the habitable zone, and may even have water on them. But that's just a starting point. So that's one of the parameters in the Drake equation. But you need a lot of other parameters not to be zero in order for that to have any meaning. So if it's hard to get intelligent life by some of the things I went through, the chances of getting intelligent life are almost zero in evolving intelligent life. Then the number of exoplanets is not really quite pertinent. I will say, though, that it's exciting to see these exoplanets, because I suspect, and this gets us into another whole part of the discussion, where it's whether you believe life evolved here on this planet or has been brought in through meteorites or space material. And I couldn't tell you either way. It seems like the environments were right early in Earth's history for the potential for a lot of the building blocks of life to develop. And even after Yuri's experiments with his grad student, we find that that a lot of the other experiments sort of supported the idea that you can get the building blocks of life. The question is, and this is a very, very big unknown. I think it's probably one of the biggest unknowns in the sciences is, how did life get here? How did it evolve or start on our planet or elsewhere? What kind of environment was required? We're a long way from knowing that until we really knock that out, because it may be very unusual for a life to evolve to begin with. And so if you have to maybe, billions of planets, if life only evolves on one of them, then your starting point is, pretty small.
Well, the origin of life is really a subject for another day. Of course, it's relevant here, but we could talk for hours about that. But
that's why I just touched on it.
Yeah, exactly. But the lightning in a bottle kind of producing amino acids experiments, I often have quoted
Miller.
Miller
and Yuri, yeah.
I have people quote back at me when I say that we have no idea how life evolved, and they just say, or what the origins of life are, and they say, well, there you go, that's how it started. But what's missing from that is another spark, which is kind of the animating spark, and that was not life was not created in that situation in those lab experiments. It was some of the materials required, and that's not the same thing. And you mentioned how life got to be on Earth, potentially coming from elsewhere. As far as origin of life goes, the panspermia idea, which is essentially, this life coming from elsewhere, this was Francis Crick's concept. For me, that just bats a problem off somewhere else, because it doesn't solve anything to say that life arrived on Earth, on a meteoroid or asteroid or whatever, because that just means, well, where did that come from?
It's important, if panspermia is the way that we get life, then it's then subsequently dependent on wherever that life formed for it to get out and populate other planets, whether it's done through some intelligent life or whether it's done accidentally. It would certainly be harder to get life on other planets if the life that came here was unusual and came from a very small source. But I think you get my point. My point is that either way, it could be that the origin of life is rare. Now, I also want you to understand that I don't get into this spark of life thing, because as a scientist, we just don't deal in those kinds of questions. I see no reason to call upon the origin of life due to some magic, and I don't mean to insult religious people. I just mean, from a scientific point of view, that sounds like magic. We want to understand how life began, and I think that's a question that science can and is addressing. The problem is that it's so complex that it may be a long time before we ever understand that.
Oh yeah, I think I used the mystical language because it is a profound mystery. Life cannot come from something that has never been alive or is dead. So therefore, what is that seemingly to primitive people? What is that seemingly magical process? That thing we have yet to understand. We may be a very long way from fathoming. What is that key? What's the missing key to that process that could allow that to happen?
Well, you bring up a good point. If I could add to that, I think unless you believe in some superior power, we have to think that life did come from an inanimate source, and that's what scientists are trying to understand in laboratories. We have viruses, for example. I think there might be some debate as to whether a virus is alive or not, but most scientists think that viruses are not alive, and yet they can replicate, and All they need is a cell to do it. So my point is that life is pretty gray, and that there is this gray area between inanimate matter and matter that is alive, so to speak.
Thinking again about the question of where all these extraterrestrials actually are, why we haven't seen any evidence, there's a few other theories I just want to throw out there that some people may be familiar with. For example, there's the prison planet idea, also called the zoo hypothesis. A variation on that is the laboratory hypothesis. The idea being that we have deliberately been isolated from life beyond Earth by species unknown for reasons unknown. And they're also popular objections to aspects of the Fermi Paradox. But for me, all of that is just more pure speculation because there's no evidence for it. And like panspermia, it moves the problem elsewhere. To speculate that there's a concrete reason why intelligent life elsewhere would not contact us, that may be the case. But again, we have no evidence. And there's a whole laundry list of these scenarios out there that potentially keep this idea of extraterrestrial life alive in people's minds, but really it doesn't constitute any evidence at all. It's just another scenario.
I can't tell you how many comments I got on my TED Talk about how we're too stupid for for intelligent life to contact us. That kind of mentality does exist out there, which surprised me a little bit. I was kind of amazed that there were that many people that thought things like that. I don't give much credence to that kind of thinking, although I do like some of, I like to think about these kinds of things. I think it's very interesting.
All of those are fascinating, as you say, sort of like, round the dinner table or bar talk, to say, oh, what if, it's the stuff of science fiction, isn't it? It's really interesting, but it doesn't, it doesn't advance the investigation any further.
Well, and you can play these kinds of games, if you want. Like, for example, there's an MIT professor that thinks that we might be in a video game and that we're sentient beings that developed in a video game. And I think that I've read some of his papers, and I think it's a very interesting idea. But it's sort of like the Matrix. Is there really a way to prove that? I don't think there is. So then you start to get outside the realm of science, and then there really isn't an absolute truth knowable to us. And so I would agree with some of the, and I never thought I'd say this, but some of the postmodern thinking which says we can't ultimately know the truth. And that may be true. We could be in a matrix. We may never know absolute truth. However, for the most part, we can know. At least we can know our environment that we live in. That is Earth.
That concludes part 1 of our interview. Part 2 will be available soon in the subscribers area at legalizefreedom.com.
legalizefreedom.com